nice of you to come. My name is Magnus. I'm from Linköping at Knowit Decision. I will talk about something called role-based security in Power BI. For those of you, if you do not know what Power BI is, I have prepared a very short presentation to introduce you on what is Power BI and why is the topic of this security a very important topic and something that we need to think about and have a strategy in order to do a large implementation for organizations in a good and secure way. So Power BI has become a central part in the Microsoft BI stack. It's a quite young product. It has been around for a couple of years, but it has rapidly evolved into being a very, very important part of the whole BI ecosystem from Microsoft. It's focused on helping organizations to become more data-driven, enable the organizations to roll out self-service analytics in the company, and also to distribute this analytic capabilities to both within the organization and with outside their organizations to their own customers. Power BI comes in many flavors and different offerings. We have the desktop application that is for modeling and doing analytics and preparing reports, which you then distribute either using a cloud service or an on-premise solution. It also has a large set of APIs for embedding these reports and dashboards into third-party applications, your own custom applications that you can develop and sell to other companies. But the core part that we're talking about when we're talking about Power BI is this set of visualizations, reports, dashboards, everything that's very visual and interactive things. A typical workflow for bringing this reports and dashboards all the way from the beginning with your on-premises data warehouse, or if you have it already in the cloud, and distributing it to your end users or your customers. This has a typical workflow, and I'd like to just present this typical workflow because it will lead us into why the security topics is a very big part of how we model our data and how we were planning on distributing our data. So a typical case is that we have divided our on-premises data sources, and then we have the cloud where we have other sources, the web sources, APIs, and software as a service sources. But typically organizations have some kind of data warehouse in place where they do all their ETL processes and gather information from their own line of business applications. Then we take information from the data warehouse, we take it into the Power BI desktop tool, we mash it up with other sources that might come from web or other external sources that we do not have in our own data warehouse. We do this data modeling and preparation of these reports and dashboards in this Power BI desktop, and then we push it to the Power BI service in some of our workspaces that we have, and then we can package these objects like dashboards, reports into something we call an app. And this app we then distribute to either specific users, groups of users, customers, or whatever. So this is a very highly efficient way to distribute large amounts of interactive data. But what about making sure that users only see what they are supposed to see, because we have gathered information from our data warehouse, we have mashed it up with other sources, we have this sort of common data model, but perhaps it contains a lot of information that some users or groups of users should not be able to see. But we do not want to maintain different sets of these data models in order to make sure that people only can access what they're supposed to access. So this is where the role-based security comes in place, and why it's a very important part in order to do a successful rollout to a large organizations, because it's inevitable that these requirements will come. And there are a lot of different requirements when it comes to this person should see this person should not see that, and so forth and so forth. So the idea is to introduce some kind of mechanism to control what the users can see with a common data model in the background. So for this presentation, we will focus on two very, very common requirements. They can come in many flavors and like small variations of these requirements, but they will show two approaches that are suitable for larger organizations, big rollouts, where we can scale this to a very, very big audience. So the first requirement that is very, very common is that we need to make sure that a particular group of people only sees a subset of this data. It might be a particular region, it might be a particular sales team, a particular department, a product group, or anything. The idea is that we have a group of people, but we have a data set that is used for different groups, and they should only be able to see their own, or at least the group that they belong to. A very, very typical scenario. The second one is that the users somehow should only see what we define as their own data, or at least some logic that tells us that this is my data and this is your data. So these users need to only be able to access their own data. But at the same time, we have other people that needs to have access to their own data and other people's data. Could be that managers, for instance, I would like to be able to see my own data, and of course the employees that is below me. So two basic security requirements that we need to have an approach that is possible to scale out in a large organization. So in order to achieve these both requirements, I'm going to introduce a basic security concept that is both in Power BI and also Microsoft SSAS, SQL Server Analysis Services, which is basically the engine that works within Power BI as well. And the concept that makes this possible is something that we call row-level security. And in order to introduce this row-level security, I'm going to show you what is a quite typical data model within either Power BI or SSAS, depending on where you do your modeling. It's shaped like a star schema. For those of you who are familiar with the star schema, this is a schema where we have a denormalized data model. So we gather our facts and transactions in some central table in our model, and then we have dimension tables that surrounds this fact table that describes these transactions or whatever that we are working with. And in order to restrict this data, because the transactions in this data are all our transactions, regardless if they are coming from one department or another department or a specific customer or not. It's the whole data model, and that's the point. We only want to have one data model that can suit many purposes. So the concept that we introduce is this row-level security, and it's basically a set of rules that we implement in a role within the data model. And these rules reference one or more of these tables that we have in our data model, and they put conditions on what must be fulfilled in order to include these particular rows of data. So all these rules will evaluate to either true or false, which will decide if that particular row of data should be allowed in the data model or not, or should be visible for the user because it's already in the data model. And then we take advantage of our relationships between these dimension tables, because typically we introduce the restricting rules on our dimension tables, not on the fact table itself, because most of the time our security requirements is based on the dimension tables. For instance, the store table, where we might have different stores that should only see their own store, different countries, or etc. So then we take advantage of these relationships that make sure that the corresponding rows in our fact table are either included or excluded when we query this data model. And the point of all of this is that this happens at the same time when a user is querying the data model. So we're not duplicating the model into different possible scenarios between the different roles. So this happens when the user is querying the data model and before anything is sent back in order to actually render a result or a visualization. Yeah, but enough of me talking. Let's do some demo on how this will be applied in an actual case. I'm switching over to Power BI Desktop, where I have this awesome looking report. It's basically our sales for different continents. We have Asia, Europe, North America, and they are selling something and earning money. But the point here is that we would like to introduce different roles for each of these continents so that they will only see each continent. They should not be allowed to see their other continents. So what we have done here is the data model itself looks just as we have seen before. So I have introduced a rule that puts a condition. First of all, I've created a Team North America role. And that role contains one rule only, and that's on the store table. And on the store table, we have the continent column. And that continent column must equal to North America in this case. So the idea is that the column continent will be filtered only to the North America, which will correspond to a set of store keys if there are many stores in North America. All these store keys will, through this relationship with the sales table, propagate to the store key in that sales table and make sure that we exclude everything that is not part of the allowed store keys for that particular region, continent, sorry. So when I have published this report into Power BI, it looks like this for me, because the owner of a data set will always have a full access. The row-level security will not even apply. They will not even try to evaluate if I am the owner of the data set itself, which is important to know. So I can see everything here. But I have another account, which I have shared this report, and I would like to access that and see how it looks. So I try to access that report, and it doesn't work. And why? This is actually the design behavior, because we have not yet associated any user with any role. So even if I have created this Team in North America role, and I have shared this report to a lot of people, even though they have access to the report, they are not associated with any role. So they cannot see anything. What I need to do is I need to make an association for that particular data set. And here I have this Team North America role, and I can see I have no user there. So I will add this other account. And once that is saved, I go back and I try to refresh this, and hopefully this works. Yeah, it does. So this person now belongs to the North America role, and the same report that we saw previously is now filtered only to the North America region. So back to this. This we have seen everything. The conclusion is that implementing such a requirement is not very big thing to do if we only have a few sets of groups that we need to have. Then we can manually create these groups, and we use a best practice would be to use 80 groups in order to keep track of who should be in each security group. So that we have, if we have 5 regions, we have 5 different roles, and then we assign one 80 group to each role, and then we manage these groups through that. But what about the second requirement? It wouldn't be a good solution to suggest that we should have one group for each of our possible users, because that's very, very impractical. So we need to come up with a way to restrict the data with only one role or a couple of roles. And first of all, this puts some requirements on the data itself, because if the business requirement is that I should only see this data and you should only see that data, there needs to be some kind of logic in order to map this for our roles. And for this case, which is a quite typical case, is that in this fact table we have an employee column or something that comes from a business application that says that this user has done this action or this transaction, so that this is the thing that will be the base of what we consider your data or my data. But we also need some way to get the information of who is trying to access this data in order to do some kind of mapping. And in Power BI, if you're using the cloud service, people will log in with some kind of email address that is linked to some Azure Active Directory account. And depending if you're having data sources that are on-premises or only stored in the cloud, there are different ways that you would like to do this. But either you have the UPN, which is basically the email address that the user signs in with, or you have some kind of domain or user account that is in your own Active Directory. So this mapping can be different depending on what kind of data source you have. But we have different DAX functions, which is the programming language within Power BI, in order to retrieve information from who is actually accessing this data. And then the most important thing is we need some kind of security structure within the data model itself that tells us if this user is accessing the data, these are the people or user IDs that should be allowed to query. So this puts some kind of extra requirements on how we model our data. So let's see how that looks in a real-life case. So I have another awesome report. It shows 3 of our employees that sells something, and we are making money. And I also included these 2 functions that we can see now. The first username function returns a domain and a user account. The second one returns the actual UPN, which is, in this case, an email address. So if we would like to make this kind of implementation, we would do it by, first of all, having some kind of table that will map incoming users, either using this UPN or our AD account. And that will be related to this security structure table. We need to have this security structure table that will make sure that when I log in, I am able to see these people. That in turn is also linked to another employee table or a user table, and that's only because we cannot, it's not allowed to have a many-to-many relationship, so we need to have a sort of a bridge table in order to reach the sales table where the actual data will be filtered. So it's a chain of relationship that makes this possible. And also one important note, for this to work, we need to enable a bidirectional filtering, because the default behavior of a filtering in a data model like this is that filtering will only apply from the one side to the many side and not from the many side to the one side. But there is settings that allows us to do this cross-filtering in the both directions. And if we also apply this checkbox, which says apply security filter in both directions, that means that the row-level security settings will respect this kind of filtering. So if we publish this report, go back. This is what I see. And now you can see this is an uploaded data source, so it's not direct linked to an on-premise data source. And that means that this username function now will return exact same thing as the UPN function, which could be a bit confusing, but it is important to know that if you're using a on-premise data source that has some kind of live connection through a gateway, this will not be the same as the UPN. So you need to consider when to use which function. How will this look for my other user? Because what I have done now, I've only added my other user to this role. Oh, I forgot to show you that role. Sorry. The role that we have now is only one role. It's a dynamic role. I have named it dynamic role, and the only filter that we have is that the column sign-in user principal name must equal to the function user principal name, so that we will retrieve the user principal name from the user accessing the report, match it with this column in our sign-in table, which will trigger a filtering all the way to the sales table. And in the cloud service, I have set this other user to be a member of that role. And for this user, when he or she tries to access this, they will see a subset of this data. For this particular user, they were allowed to see 2 of our 3 employees. So that's what they will see when they log in. So, a short recap. This was what we just saw. So, for a simple requirement where we only need to divide our data into a small number of groups, we apply different roles for each of these requirements. If we have a more complex scenario where the security structure is a bit more complex, we introduce the security structure itself into the data model. It's much easier to maintain such a data security structure in a database that we can control, or we can integrate it with our HR systems or anything that has this information. And then we do it in an automatic way, and then we only have one role where everybody is a member, and this is the dynamic role. Oops, sorry. So that's the way we tackle the scenario like that. So that's basically those two requirements that require a bit different approach in order to fulfill them. But there are other kinds of requirements. I will not have time to go into this bonus scenario, but you can take a look at the presentation that will be uploaded somewhere, and then we can discuss that some other time. But there are always other more complex cases. For instance, if we take the first example, we have restricted the North America group of people to only see the North America sales. So, for instance, they see that we have sold something for 1.5 million, and the grand total for that report, when they look at it, it will show 1.5 million. What about if we say they should not be allowed to see the other continents, but they should be allowed to see the grand total in order to see, okay, we are contributing this much to the total the grand total sales. So this is another more complex scenario where you need to do some creative modeling in order to achieve this, because as of today we don't have full support for this kind of security requirements within Power BI. But they're absolutely possible to solve, but it will require a bit more creative ways, unfortunately, today. So that's all I was planning on talking about today. Are there any questions on this? No? Yep, okay.
I have a colleague that has been working with Power BI, but
It all depends actually, but the Power BI desktop is capable of doing a light version of ETL process as well. So you can hook it up to web services or databases or Excel files or whatever, and then you do all the data modeling and preparation within the tool itself. So that's fully possible. But depending on how large project we're talking about, we often want to move steps further back in the data modeling and a data warehouse. But it's fully possible to do the data modeling and all the analytics and visualizations within the desktop tool.
So basically, if you have an SQL server in the back, and then you have your data warehouse, where is the data warehouse? Where does it reside?
The data, I didn't understand.
If you have like your customer's SQL server in the bottom,
Yeah.
and then you want to do something in Power BI, you need a data warehouse. But where is that?
You don't really need a data warehouse because if you do an import mode, which is the most typical you do in the Power BI, you will retrieve the data from the customer SQL database, and it will reside within your own client. I mean, within the desktop itself. Yeah. Okay. Then I would say thank you for coming.